Chapter 8, Section 4, Day 1 is all about rational expressions. Rational means fractions. So we're going to talk about how we can multiply and divide fractions and divide rational expressions because of it. Rational expression is the quotient of two polynomials, which means a fraction. The value of the polynomial expression in the denominator can't be 0. So that means anytime you have a denominator or a division, you have to make sure that 0 doesn't end up on the bottom. That means that you have to have excluded values, values that aren't allowed because they'd give you 0 on the bottom. That's part of your answer. You have to list those excluded values. So before we start simplifying those expressions, we want to talk about excluded values. Excluded values mean what values would make the denominator 0. So if you take a look at the first one, anytime it's just a letter and no adding or subtracting, the excluded value is 0. So that R value can't be 0 because if it was, you'd get 0 in the denominator, and that's not okay. If you take a look at letter B, that's considerably different. Take whatever the denominator is and factor it first. Taking a GCF out leaves me with a D minus 2. So this one right here, the D out front, means that D can't be 0, and the minus 2 means that D can't be 2. So I have two restricted values there. So if you take a look at letter C, you're going to have to factor that. Factoring the denominator gives me x plus 3, x plus 2, because two numbers that multiply to 6 and add to 5 are 3 and 2, which means that my exclusions are negative 3 and negative 2. A rational expression is in simplest form if your numerator and denominator have no common divisors or any common factors are taken away. So we're going to look at simplifying each rational expression and identify any excluded value. To be honest, I do them out of order, so I do excluded values first. If you take a look at letter A, T can't be 0. There's no addition or subtraction, so it's just 0. What they're asking you to do is to simplify, to reduce. So you can reduce numbers and letters separately. A 3 over 12 reduces to a 1 over 4. 3/12 is 1/4. And for the letters, you subtract the numbers in the air. T squared over T is T to the first on the top because it's top heavy. There are more T's on the top than there are on the bottom. Now, you can leave the 1 there or you can get rid of it. It doesn't matter. I'll get rid of it so it's a little prettier. So your final answer is T over 4. For letter B, I'm going to do restrictions first. X and Y can't be 0. No addition or subtraction, so all letters are 0. To simplify, 4 over 16 reduces to a 1 over 4. X over x squared reduces to an x in the bottom because it's bottom heavy. And y cubed over y is a y squared up top. 3 minus 1 is 2. So you'll notice if you do your restrictions first, any variables that cancel are still a restricted value. So even though y went away, it's still part of your restriction. Restrictions for letter C, x, y, and z can't be 0. Do them first, because if they cancel, they're still part of your answer. A 12 over 15 reduces to a 4 over 5. X over x squared, it's bottom heavy, so there's an x left in the bottom. Y squared over y is top heavy, so there's a y left up top. And z to the fourth over z to the fifth is a z on the bottom. So even though the y disappeared from the bottom, it's still a restriction. All right, simplify each rational expression and identify any excluded values. Again, I'm going to take care of exclusions first. In letter A, you probably should factor first. Let's factor. So you can't factor the top, but on the bottom, you can take out a 3, leaving you with an x plus 3. And the reason I said you should factor first is because it's easier to see the exclusions here. The exclusion on letter A should be negative 3. X can't be negative 3 because that's the root you would get from that factor. Once you do your restrictions, cancel what you can. The 3 and the 3 cancel, and I'm left with 1 over x plus 3. All right, letter B. I'm going to factor the top first. The GCF there is a 2x, which leaves me with a 2 plus x. At the bottom, I have a 4x. So take a second once you factor and do your restrictions. X can't be 0. There's no addition or subtraction on the bottom, so it's just 0. The canceling on this one's a little odd. The x's go away, and the 2 over 4 becomes a 1 over 2. So my final answer is 2 plus x on the top, with or without parentheses, doesn't matter, and a 2 on the bottom. Pay close attention to the fact that you can't cancel the 2 on the bottom with the 2 on the top, because the 2 on the top is linked to the x, and so they can't cancel. All right, letter C. Nothing can be factored, so I'm just going to start right away with restrictions. X can't be 3. Those are my restrictions. And in letter C, that's my final answer. I can't cancel, I can't simplify, I can't do anything else, so it's just x plus 3 over x minus 3. Letter D, I'm going to factor first. X plus 3, x minus 3 on the top, that's the difference of squares, and then x minus 3 on the bottom. Based on that denominator, x can't be 3, that's my restriction. And for canceling, this cancels with that, and all I have left is an x plus 3. Letter E, the GCF on the top is a 3x, which leaves me with an x plus 4. On the bottom, the GCF is a 2x, which leaves me with an x plus 4. So before you reduce, take a second and do your restrictions. Based on the bottom, x can't be 0 because of the 2x, or negative 4 because of the x plus 4. Cancel. The x's cancel, and the x plus 4's cancel. So my final answer is 3/2. Pretty overcompensated on that one.